Welcome back, students. This video is for the students of class 9th, subject science. It's your chapter number 11, that is work and energy, and this is your lecture number 3. So students, in today's lecture we shall cover the following topics. Number 1, law of conservation of energy. Number 2, what do you understand by power? Number 3, the commercial unit of energy. Okay, so let's start with today's lecture. Your first topic of today's lecture is law of conservation of energy. Okay, what this law states? It states that energy, it can neither be created nor destroyed. Okay, it cannot be created nor destroyed, but it can only be converted from one form to another form. Okay, energy can be converted to one form to another form, and it is not created nor destroyed. Or you can also write in other words that the total energy before transformation is equal to total energy after transformation. Okay, I already told you energy is converted from one form to another form. So before the conversion, before the transformation, the total energy, it is equal to the total energy after the transformation. Okay, or what we can say, the total energy of the system, it remains constant. Okay, the total energy of the system remains constant. So are you clear about this law? Now we shall derive an expression, or we shall derive how the energy is conserved during a free fall. I am considering this case of free fall when the object is placed at some height. Okay, this is some height at which the object is placed. Let this point be A. Now from this height the object is falling downward, means it is under free fall. What do you mean by free fall? When the objects are falling freely under the gravitational force alone. So that object is said to be free fall. So this object is falling downwards. Okay, it is in free fall condition. So initially it is at point A. Okay, at this height it is placed, means we can say it is at stationary position. Now it is coming downward. So the final position, let the final position at the ground level, it is at C. Okay, point A, the initial position of the object when it is at stationary, and point C when the object has reached during the free fall to the ground level. And this B, I have taken any point between these 2 points A and C. Okay, now what is H? This total distance from A to C, I have taken it as H. And X is the distance between point A to point B. Okay. Now what is BC? BC will be what? It will be H minus X. That will be BC. Clear, students? So this is the condition we are assuming that the object is in the state of free fall. Now what we will do, we will derive the total energy at point A, the total energy at point B, and the total energy at point C. And what you will see that the sum of kinetic energy and potential energy at all the 3 points, it remains constant. Okay, the sum of kinetic energy and potential energy at point A is equal to at point B is equal to at point C. So let's start with the derivation now. What is total energy? Total energy is potential energy plus kinetic energy. Okay, students, before deriving the equation, let us consider these points. What is M? M is the mass of the object. U is the initial velocity. V is the final velocity. S is the displacement. A is the acceleration. Why acceleration? Because there is initial velocity and final velocity. So obviously there is change in velocity. And what is change in velocity? That is basically acceleration, the rate of change of velocity. Okay. So we have to assume these things: M, U, V, S and A. Okay. Now students, we will find out the total energy at point A, then the total energy at point B, then the total energy at point C. So let's start with first part, the total energy at point A. Total energy, it will be equal to kinetic energy plus potential energy. Okay. Now what is kinetic energy at point A? Since the object is at rest, it is at stationary position, so the velocity is 0. And what is kinetic energy? Kinetic energy is half mv square. If velocity is 0, so the kinetic energy becomes 0. The kinetic energy will be 0. And what will be the potential energy at point A? Potential energy, that is mgh. Okay, m is the mass of the object, yes. G is the acceleration due to gravity. Yes, G is acting downward. You can write this. G is acting downwards. And what is the displacement at point A? Displacement is the distance between point A to point C. That is basically h. So the potential energy becomes mgh. So at point A, kinetic energy is 0 because velocity is 0 and potential energy is mgh. So the total energy at point A becomes kinetic plus potential, that is 0 plus mgh, that is mgh. So the total energy at point A is mgh. Clear students? We are adding these two equations. Now we will find the total energy at point B. Again at point B, what is total energy? Kinetic energy plus potential energy. What is potential energy at point B? M, G. What is displacement? Displacement is distance between point B to point C, because we need to calculate at point B. So this distance will be h minus x. So the potential energy becomes mg h minus x. Okay. Now we need to find kinetic energy. What is the formula of kinetic energy? Half mv square. Now we need to find out what is v at point B. At point B, the initial velocity, since the object is falling downwards, it is under the condition of free fall. So it means it has some initial velocity and there will be final velocity. Initial velocity will be this much, which is at point A, and final velocity will be v at point B. Okay, so what is initial velocity at point A? Initial is 0. At point B, the initial velocity, it will be 0 because it is falling from point A. Okay, so at B, the initial is 0. And v, let it v be the final velocity at point B. So apply the third equation of motion. V square minus u square is 2gh. What is v? V is the final velocity at point B. Okay. What is u? U is 0. 2. Acceleration is g here. Yes. And what is height? At point B, it will be x. Because at point B, the displacement is what? X. This much distance. So v square becomes 2gx. Now substitute here the value. Half m v square, that is 2gx. So 2 cancel with 2. You will get mgx. So mgx is the kinetic energy and mgh minus x is the potential energy. Add these two equations. So it will be mg h minus x, that is potential energy, plus mgx, that is kinetic energy. Now open the bracket. mgh minus mgx plus mgx. Now minus mgx and plus mgx, they will get cancelled. So you will be left with mgh. Clear, students? Again I am repeating, at point B, the potential energy will be mgh minus x, and kinetic energy, for that we need to calculate what is v. So initial is 0 at point B, acceleration is g, displacement is x. So v square minus u square is 2as. So v square, u is 0, 0, 2, a is what? G, s is what? X. So v square is equal to 2gx. So what is kinetic energy? Half m, v square is 2gx. So 2 cancel with 2, it will be mgx. So add these two equations, potential energy plus kinetic energy. You will get your answer as mgh. Okay. At point A, it was mgh, right? At point B, it is also mgh. Now let us calculate at point C. So at point C, again total energy is E, kinetic energy plus potential energy, right? At point C, since the height is 0, displacement is 0 now, and so the potential energy will become 0, because potential energy is what? mgh, height is 0. So the potential energy become 0. Now we need to find out the kinetic energy at point C. Okay. Now apply the third equation of motion. V square minus u square is 2gh. What is the final velocity at point C? V. Okay, v square minus, what is the initial velocity? Initial is 0 at point C. So it will be v square minus 0 is equal to 2. G is acting downwards, yes. What is the displacement at point C? It is h. Okay, at point C, the displacement is what? Total h. So v square is 2gh. So what is kinetic energy? Half m v square, 2gh. Cancel, mgh. Clear? So kinetic energy is mgh and potential energy is 0. So sum it, mgh plus 0, that will be mgh. So again I am repeating, potential energy at point C becomes 0 because the displacement is 0. So potential energy is 0. Now we need to find out kinetic energy at C. For kinetic energy, use the third equation of motion. V square minus u square is 2gh. Now u is 0. So v square is equal to 2gh. H is a displacement. So half m v square 2gh, that will be kinetic energy. 2 cancel with 2. It will get mgh. So what is the total energy? Potential energy plus kinetic energy. 0 plus mgh, that will be mgh. Okay, so we derived at point A, total energy is what? mgh. At point B, it is also mgh. At point C, it is also mgh. So the total energy at any point, it remains constant. Okay, the energy remains conserved. Okay, so this was all about the law of conservation of energy. This was a condition of free fall, when the object is placed at some height and it is falling vertically downwards. Clear, students? Now moving ahead to our next topic, that is power. What is power? Power is basically what? It is the rate of doing work. Okay, power is rate of doing work. So what will be the formula? Work done upon time taken, because it is given a rate. I always say that whenever rate is given, write divided by time. So what is the formula of power? Work done upon time taken. Okay, students. So we have got the formula. Power is work done upon time taken. Or in short form, we can write down P is equal to W by T, where P is power, W is work done and small t is the time taken. This is the first formula to calculate power if work and time is given. There is one more formula to calculate work. Power is force into velocity. Okay students, I am repeating. First formula is work done upon time taken. Second formula is force into velocity. These are the two formulas to calculate power. Now, what is the SI unit of power? You can derive from this. SI unit of power. Power is what? Work done upon time taken. Right? Now, what is the unit of work in SI unit? Work done, it is joule. And time we take in second. So, joule divided by second. Joule per second. Okay, it is joule per second. And this we write as watt. W-A-T-T. Watt. Why watt? Because this term power, it was discovered by a scientist named as James Watt. That's why the SI unit of power is also named after his name, watt, that is represented by capital W. Okay, so work done upon time taken is joule per second, that is basically equal to watt, represented by capital W. So what is the SI unit of power? Joule per second or watt. Now, how to define 1 watt? How to define 1 watt? If 1 joule of work is done in 1 second. So, power is 1 watt. Okay, you can write down. If 1 joule of work is done in 1 second, power is said to be 1 watt. Okay, you need not to cram. You can just write down from the formula itself. That is very easy. Clear students? So what is power? What is the formula? And what is the SI unit? There is one bigger unit also, kilowatt. 1 kilowatt is basically what? 1 kilowatt is equal to 1000 watt. Or we can say 1000 joule per second. Why joule per second? Because we already discussed joule per second is watt. So I have simplified this watt, that is joule per second. So 1 kilowatt is 1000 watt, or we can say 1000 joule per second. Clear? This is the bigger unit of power. Clear students? So this was all about power. There is one more term given in your NCERT book, average power. What is average power? Average power will be total work done upon total time. Okay. So what is average power? Total work done upon total time taken. That is average power. Or we can write what is total work? The total energy consumed upon total time. That is also average power. One and the same thing. Because work and energy, they are basically similar things. Energy is what? Energy is the capacity to do work. So we can replace work by energy also. It hardly matters. So average power is total work done upon total time taken, or we can also write total energy consumed divided by total time taken. That will give the average power. So this was all about power, the formulas, the SI unit and the average power. Clear students? Now moving ahead to our last topic of this chapter, that is commercial unit of energy. Okay, the commercial unit of energy. What do you mean by that? Or what is the unit of it? What is the unit of energy that we discussed? The unit of energy is basically joule. But this is a very small unit. Okay, this is too small and it is very inconvenient to express the larger units of energy. Okay, so there is one bigger unit of energy that is called as kilowatt hour. Okay, joule is the smallest unit of energy. There is one more bigger unit, that is kilowatt hour. Or you can write in short form kWh, kilowatt hour. K for kilo, W for watt, H means hour. So kilowatt hour is the bigger unit of energy, or we can say the commercial unit of energy. Now the question arises, what is 1 kilowatt hour? What is 1 kilowatt hour? It is the energy used in 1 hour at the rate of 1 kilowatt. Okay, what is 1 kilowatt hour? It is the energy used in 1 hour at the rate of 1 kilowatt. Okay, when 1 kilowatt, the power or the energy, it is used in 1 hour. That is 1 kilowatt hour. Or what we can write? Let us derive the relationship between kilowatt hour and joule, because joule is the smallest unit of energy and kilowatt hour is the bigger unit of energy. So let us derive what is the relationship between these two. You know that 1 kilowatt hour is basically 1 kilowatt into 1 hour. Okay, 1 kilowatt into 1 hour. That is the short form, we can say 1 kilowatt hour. Now what is 1 hour? 1 hour is basically 3600 seconds. And what is 1 kilowatt? 1 kilowatt is 1000 watt. So 1 kilowatt hour is equal to 1 kilowatt into 1 hour. 1 kilowatt is basically 1000 watt and 1 hour is 1000 second. So 1000 into 3600, that will give 36 into 10 to the power 5, because how many zeros? 1, 2, 3, 4, 5. So 36 into 10 to the power 5 watt per watt second. Watt second is what? Joule. Okay. How joules? We know that power is work done upon time taken. Power is watt and work done is joule and time is second. So watt into second, that will be joule. Okay. So watt into second, that's why I've written joule. Okay. So 36 into 10 to the power 5 joule, or you can convert into one decimal also, 3.6 into 10 to the power 6 joule. Okay, this is the relationship between 1 kilowatt hour and joules. The smaller unit of energy and the bigger unit of energy. Okay. So the energy which is used in households, industries, they are usually expressed in this kilowatt hour, the bigger unit of energy. Okay, for example, we say that the electrical energy used during a month, it is expressed in the term of units now. Okay, you might have seen at your homes when the bill comes of your electrical energy, it comes in units. How many units have you consumed? So what is what? That 1 unit is what? 1 unit is 1 kilowatt hour. Okay, 1 unit is 1 kilowatt hour. And you know what is 1 kilowatt hour? That is 3.6 into 10 to the power 6 joules. Clear, students? So this was all about the chapter. That's it. Today we discussed about the law of conservation of energy, power, and the commercial unit of energy. The relationship between joules and kilowatt hour is very, very important from the examination point of view. Okay, this question is generally asked in the exams. So that's it for today's lecture. What is your homework? Your homework is to solve examples 11.7, 11.8 and 11.9 given in your NCERT book of chapter number 11, work and energy. Along with examples, you have to solve the in-text question number 1, 2, 3, 4 given on page number 156. These are just basically covered in the notes. Okay. And after that, you have to solve exercise question number 3, 6, 7, 9 and 10. Okay. This is your homework for today's lecture. The rest questions we shall cover in the next day. Clear, students? So that's it. Thank you. Have a nice day.